Perfect. Thank you very much. Thank you for coming to Veracode today. I have presented in the past, and I've not presented to such a large audience, so really appreciate you all coming. The purpose of today's talk is to go through trusting AI to fix your code, genius or cyber suicide. Just to give you a bit of an intro into who I am, I'm a senior solutions architect at Veracode. But without further ado, can I just ask the audience, is there many of you based in the security space? Can I just get a show of hands? Many of you working in security? Many developers in the audience? Well, quite a few. Anyone in the application security space? Okay. Oh, couple in the back. You guys are from Veracode, doesn't count. Right, so I'm a former software engineer. I was a Java developer in the past. I'm about 12 years in the software space. To be honest with you, the reason I'm doing this talk today is simply out of concern and a cautionary tale. Primarily, I've been focused in the security space the last number of years, simply out of passion. I'm also a huge cybersecurity enthusiast as well as a rock climber. But let's get into the content. A couple of different things I'm going to walk through today. Primarily, what is the current state of the AI software security space? So just to give you an insight, I've pulled together some resources from a State of Software Security report, which is something that Veracode produces annually, as well as Sneak report, Gartner report. So the sources are referenced at the end of the presentation. I'll be sharing the presentation post this demonstration, so you can refer back to it. Also looking at the current issues and risks we see across the board with generative AI. Building an AI product in the application security space. I want to give a heads up. I'm not doing a sales pitch. I know I work for Veracode. I'll be presenting a Veracode product, which is Veracode Fix, which is an AI-based remediation service. Just to give you a heads up, it's my own personal view and my own take on this. I'll walk you through what a vulnerability is, where do I see the future of the application security space, and some takeaways and cautionary tales. Okay, so this is a slide I've actually taken from something I demo to clients day in, day out. This is our sort of download of the state of the AI software security space in a whole. Probably the most prevalent one, which is why you guys are all here today, the LLM models, the AI code generation and risk. And genuinely, this is absolutely exponential. It's pretty obvious at the moment, and you'll see some of the stats that I produce, but that's kind of sitting at the top. We also see a whole load of regulatory and compliance focus coming in. So the likes of DORA, that's kicked in about a month ago, ISO 27001. So it feels like there's momentum in this space. There's an increasing pressure from regulatory boards, countries across the board to push for better and safer software security. Growing security debt, that's probably a result of the first piece, so AI code gen and risk. Developer influence, something we see a lot more developers sort of stepping in, playing with these tools, but also advocating for software security. And vendor rationalization, simply picking out customer software vendors, depending on if they've actually secured their code. Can you all just give me a hand? Can you hear me down the back? All good? I apologize, the screen's not as large for some of you in the back, but the recording will be shared as well as the slides. Okay, so to get into the current state, this is from our State of Software Security report. Some big numbers here. 70.8% of organizations have security debt, which is what we've gotten out of this report. But most importantly, 45.9% of organizations, per our analysis, have critical security debt across the board, which, as you can imagine, presents huge risks to businesses. Very high severity. So we base it on CWE, CVSS scoring. Sorry, I probably should have mentioned, I'm pretty interactive. So if you have questions throughout, ask me questions. I will leave about 5-10 minutes towards the end of the call as well. But session is for you guys. Depends on data, yeah. So we produce a report annually. Yeah, exactly. So where is this security debt? Well, while first-party code constitutes almost 90% of all security debt, 65% of this critical debt is actually coming from third-party code and open source libraries. Open source libraries are, I'm making a call to, let's say, some kind of external library. So I'm not writing the code, I'm referencing an external package or external piece of code. Some more of our research. Now, this is across the board last year, out of all the applications that we scan. Bit of an intro to Veracode. We're an application security company, so we produce static as well as dynamic scans. A static scan is essentially looking at a source code, so peeking into the source code and analyzing its security. Dynamic scans are a black box type approach where I don't see the repository and I'm simply just pointing a scanner towards it, so I don't have access to the source code. But across the board, we draw the following. So over 1 million applications scanned, 1.5 million dynamic, and 11 million static analysis scans. And we've produced 96 million raw static findings, 4 million raw dynamic, and 12.2 million raw software composition analysis findings. Why do I say all of this? A couple more stats here that I've pulled off from some of these reports. Prevalence is 60% of organizations have incorporated AI-assisted development tools into their workflows. Can I just get a show of hands? I know quite a few developers. How many of you are using the likes of GitHub Copilots, ChatGPTs for generating code? A lot of hands, exactly. So, and this is on the increase massively. And I'm not against it. I'm totally an advocate for this, but it also means that the software security space is becoming harder because of all this new code that's been generated. Yeah, it's on the increase. So this was from 2023. So yeah, it's incrementally increasing. But good question. So 48% of DevOps pipelines now include AI-driven automation. 55% of AI contributions to open source projects. This one baffles me. So 80% bypass security policies to use AI. I'm not guilty of this for sure. But only 10% of scans scan most of code. About 58.7% of application security teams are just simply struggling to keep up with all this new code being generated. 55.1% organizations now consider AI-generated code as part of their software supply chain. And 56.4% of devs commonly encounter security issues in AI code suggestions. And this is probably the biggest difficulty of this, is that we have all of this AI-generated code. However, is this reintroducing security issues when we're generating this code? Okay, so it's probably a good point and segue to move into the issues and risks associated with GenAI code. I've taken off the OWASP top 10. OWASP is a foundation in the application security space. They love their top 10s. They're producing reports on different areas, laser focused on LLM security right now. So perhaps I'll take maybe 5 of these. I just call them out. I appreciate it might be slightly small towards the back, but the most prevalent one in terms of LLM security is prompt injections. So that's manipulating user inputs to alter LLM behavior or access unauthorized data. Example of this is injecting prompts to access private information. Second one, sensitive info disclosure. So unintentional exposure of confidential data in model outputs. So the likes of leaking API keys, user credentials. Supply chain vulnerabilities. So to name an example here, the SolarWinds type attack, risks from malicious or unverified third-party components, so integrating LLM libraries with backdoors. I see this one increasing more and more, the data and model poisoning, so effectively manipulating training data to introduce vulnerabilities or alter LLM behavior, so inserting harmful instructions in the data. I'll take the 5th one. I won't read all of these out. You guys can have a read once we share these slides. The 5th one is improper output handling, so lack of validation leading to harmful or biased outputs, so generating harmful language. Okay, so I'm going to talk about how we went about building an AI product in the application security space. So this is our Veracode Fix product. The sort of motivation behind this started early 2020. I spent time with some of our research engineers as well as machine learning engineers just to understand how they went about designing this. But ultimately, the motivation behind this was we have an array of static scan products. So these are the products that scan your code, check for security vulnerabilities. We had powerful analysis algorithms, coverage of lots and languages and frameworks. By the way, if you want a good definition for algorithm, that's one right there. careful modeling of sources, sinks, and propagators. And we scan trillions and trillions of lines of code. We give our customers great information, but what should we do next? This AI revolution is upon us. We've told customers exactly why their code is broken, but ultimately, and this is probably the holy grail of AppSec, is how do you go about fixing it? You know, you can produce any amount of reports and findings on vulnerable code. However, you know, it's you guys, the developers, that need to go in and actually fix these ultimately. So, and it also requires specialized knowledge, how to fix a flaw, and lots of fun, not fun work, as I mentioned, making the security fixes. As a result, a lot of security debt. So we went about thinking about the solution. The solution was some form of automatically fixing the flaws. We've known about the fixers, they're well known. We sanitize outputs for cross-site scripting, use prepared statement for SQL injection. These are very generic terms in the AppSec space, and mostly straightforward code modifications. So, woohoo, let's use AI, right? That seems like a good fit for us. So the idea was to use AI to map good code to bad, or map bad code to good code. Sorry. However, there are challenges here, right? So how do I go about representing the code? How do I train the AI to fix the code? Do we need to identify the location and nature of the flaw? How do we make sure the fixes are good, so it's syntactically correct, semantically correct? And how do we generalize for many different languages and CWEs? CWE is just a framework for being able to classify vulnerabilities. It's a bit of a timeline. I mentioned 2020, so we had an incubator project and early research looking into auto remediation. Our early analysis was actually around code rewriting techniques as opposed to GPT models. So, however, what we found practicing and implementing this, there was too much manual work to write the application security fixes, configs for each CWE, language pairs, and easily thousands of rules needed to be written. GPT, we initially chose GPT-2 before we acquired a company called Jaruna. The reason for this, we knew that the model is open source, so we could use it however we wanted. Later models like GPT-3 and Codex were only available through APIs. We also knew very specifically that we wanted a narrow application of GPT, so two different categories, narrow versus broad. Broad effectively means you have the ability to provide prompts, you have ability to manipulate. So very narrow, just fix security in code. That's all we wanted to do. 2022, we went about acquiring a company called Jaruna, which leverages general reference patches and then intelligently figures out, I'm no machine learning engineer, so don't have too much insight of how all this works, but we figured out how to translate it to the customer's code situation rather than us manually writing every single edge case. So very quick slide. So this is Veracode Fix, an AI-assisted remediation solution that I went through that addresses the individual findings or whole categories at once. Languages that we support, Java, C#, JavaScript, TypeScript, Kotlin, etc. And currently, by the way, there is a demo of this so you can see what this looks like in real life. It's available via a command line interface as well as IDE plugins, so your development environments. This is one of the main slides and backed up by research. So when we went about having a look at this, what we tended to find is a lot of the use cases were problematic by design. So looking at open source data sets, systematic flaws, IP license issues, and with the problematic by design as well, you have the self or semi-supervised learning, which you can end up with model poisoning, prompt injections. You've also got kind of risky suggestions, so IP legal issues, hallucinations, vulnerable to attack vectors, which is why we chose a responsible design, so trained on a curated data set of patches. Excels are generating secure code fixes, and you don't have these bad guys here, right? The model poisoning, prompt injections, because it simply doesn't exist. It just applies the code fixes as opposed to allowing the user to make any inputs to it. A bit more of an insight how this is trained. So it's a simple equation here, D is equal to A plus C minus B. A is your vulnerable code, and where you want to end up is your fixed code. In between that, we have a vulnerable reference and then a fixed reference. So you're basically given it all 4 elements, so it can learn to sort of work backwards from vulnerable code and to end up at the fixed code. We've trained it on good code samples using Veracode created sort of reference patches. Where is my demo? Okay, it's coming after this. Okay, before you see the demo, this is a vulnerable piece of code. So I'd like to ask the audience, does anyone know why this code is vulnerable? Straight in the back. Yeah. Yeah, you're right. You're on the right track. So maybe I should just explain what this piece of code is doing. It's making a HTTP request. You've got a string, effectively, that you're then storing into an array, a string of name, which you're then outputting onto whatever it might be, a web application or such. So right now, this is not checking any form of inputs. So anyone else? Does anyone know what type of attack this might be? Close. Any other AppSec vulnerabilities that you know of? There we go, cross-site scripting. Bonus points, do you know the CWE number? Yeah, you're right, it's cross-site scripting. It's CW80, which the thing is that the interesting part of this is prevalent for like 20 odd years, and it's still one of the common occurrences in vulnerabilities. Basically, the reason this is vulnerable is you're saying that you're getting a name parameter here, and if you've got funny characters, so you can manipulate the input to produce an output that you're not expected to receive. So here's a fixed part of this. So effectively using a HTML cleanser, I've got a piece of information here for you guys to review if you wanted to per the slides, but it's basically sanitizing the inputs and just checking that there's no strange inputs or funny characters being inputted. So that's kind of a fix to a cross-site scripting attack. Okay, so the actual demo. So what you can see here is VS Code. It is a Veracode plugin, so it sits within the IDE. So this is the AI-based remediation. Essentially, this is a Java application, so a vulnerable application. I've run the scan, which is run a SAS scan, an SCA scan, so a couple of security scans, but essentially what it's doing here is bringing you to a piece of code. So you would select the vulnerability or flaw in your code. It would do a git diff comparison and helps you out to fix the security issue. This particular one is an SQL injection. So it effectively generates and allows you to apply a fix directly within the IDE. So that's sort of the responsible by design, as well as you can see here, there's no way to add any inputs or prompt injection. It's simply just looking at the code and allowing you to apply security fixes to your code base. Okay, so I actually inputted this into ChatGPT. I was just curious to see what it would produce as an output. So where do we see the future of the application security space, which I was curious about? So I think possibly a buzzword here, the shift left security. And this is one of the reasons I'm doing this talk, is being able to integrate security earlier into the SDLC with tools like security scanning tools, so SAS and SCA. Seen across the board, cloud native security, so focusing on securing microservices, containers, serverless architectures. The big one here, AI and ML driven security, so leveraging AI and machine learning for faster, more accurate vulnerability detection, but also threat analysis. Supply chain security, so the ability to strengthen third-party risk management and securing software dependencies, and zero trust models, so adopting zero trust architecture for continuous identity verification, also invoking and allowing least privilege access to different systems. So takeaways and cautionary tales. The reason I've introduced this slide, and if I can just say to all of you in the audience, if you can take away one thing out of this, that would be absolutely awesome. Whether that is you've learned about cross-site scripting or OWASP, and I'm advocating go ahead and play with models, see how they behave, see how you can attack them. But this is the reason I am in application security. So the barrier for entry is much lower for generating cyber attacks, scams, impersonations, and I feel like as a community, as people in the space, we really need to be the voice of pushing for guardrails and implementing security practices for these. Some of these cyber attacks, while not specifically related to AI, it's no longer just identity theft or I've stolen credit card details. It's attacking power grids, right? So the nuclear facilities, the infamous Stuxnet attack in Iran, ATMs, the Carbonek attack, endless money printing, or endless money producing, pacemakers, like they've been able to exploit Medtronic pacemakers, and cars. Like imagine driving your smart car and there was a Jeep Cherokee hack in 2015, back in 2015. I mean, imagine how much more sophisticated these attacks can be now. But this power grid one is something that happened multiple times. And it's, if you think of taking down a power grid, what happened in Ukraine specifically is that people weren't able to access ATMs because the power is out, which meant when trying to do shopping, I couldn't use my card and people ran out of cash. So like these are real life attacks happening before our eyes. And to me, it just feels like we're in an attacker versus defender mode with this AI revolution that is happening before our eyes. I took a screenshot of Hugging Face. Can I get a show of faces or hands? How many people are familiar with Hugging Face? Okay, a lot of hands. So I took the screenshot about 2 weeks ago, and I only noticed when I did my last presentation, the DeepSeek AI model, DeepSeek R1 only had 131K downloads. I'm sure this has hit a couple of million at this point. It's just the speed of this. And also the model count, I looked at this a couple of months ago. This was 700,000. So this is increasing absolutely exponentially. I love Hugging Face, don't get me wrong, I've used it. However, Forbes released a recent study. They were able to identify thousands of files containing hidden code within these models. There was a JFrog security researcher as well. Same thing, they found hundreds of models that had backdoors. So when I download these models, I'll have it self-contained on a separate machine. Yeah, just to point out. And these guys are the bad boys. So I don't know how familiar you guys are with unrestricted GPTs. Yes, they exist. They're on the dark web. Two examples of these are Fraud GPT and Worm GPT. And the reason I'm pointing this out is this is incredibly elevating the attack vector. I mean, I've played around with some of these models, and it's not that difficult to knock the guardrails. But when you have the likes of these, where there are no guardrails, like generating a DDoS attack or a cross-site scripting attack, the barrier for entry. I no longer need to be a developer. I no longer need to know about security. I think these are paid licenses. Full disclaimer, I've not tried them out, but it's just showing that the barrier to entry is much lower. But without further ado, I'd like to thank you all for listening, and I hope that's been a cautionary tale. So I'd like to open up to the audience for questions. Wow, there's a lot of hands. Do we want to pass mics to Bor, or what's the best way to do it? Have you got a second mic?
Does this work?
That's a good question.
I don't have tech support. So I think, can you talk loudly?
Yeah, sure. Okay.
In one of your first slides, you were showing that about 2/3 of the critical ones are from third-party libraries, which also makes me think, but there is a lot of that is automatically detected by, say, by GitHub or other NPM or whatever you want to use. In your experience, from your point of view, as Veracode analyzing the code base of different companies, is something that gets quickly fixed, say, as soon as there is a vulnerability, say within 1 week, people are fixing that, or is something that instead is going to stay because people are a bit more lax despite this notification? So it's also a cultural thing, if you want, in terms of development flow and so on, or why does it happen so much? Why 2/3 of that is from libraries? and how long do they stay?
Yeah, I think third-party components are definitely on the increase in terms of attack vector. So yes, sure. So for everyone, the question was around third-party libraries or third-party components. Is there a prevalence in the increase of use of this, and how do we see this from a research perspective? Yes, I think there's 100% an increase. We do analysis against national vulnerability. Yeah, sure. Does that work? Does that work? Perfect. Just put my water bottle down, guys. Yeah, so there's definitely prevalence in the increase of third-party components, and the reality of it is, I actually read a report today, is that a lot of the third-party components, so utilizing the infamous Log4j or JBoss, and we all use these as developers. However, the problem is that there's increased code generation to these open source libraries, third-party components, which is now rendering an increased risk to that overall. So, but a good reference to this is the National Vulnerability Database. So we have a team of security researchers that analyze and curate these data sets, but it's mainly because of the exponential increase of code gen with AI. Yeah.
Thank you for the talk.
You're welcome.
Very insightful. I have a question. How do you integrate Veracode solution into software developer lifecycle and to the daily life?
Yeah.
Is it like a pull request kind of trigger, or maybe daily scan, or monthly practice that you encourage people to follow? Please share.
Yeah, there's different ways. So one of them is the IDE, which you saw earlier. So you can integrate scans into the IDE. We also integrate into CI/CD, so your GitLab, GitHub, directly within the pipelines. So at each and every pull request or commit request, we can analyze your code. We've also got a web-based application whereby you upload and scan. So it really depends on the use case and what works best, but ultimately we scan binaries or open source code. So whichever fits in the developers or security teams, security teams lifecycle. There are a couple more questions. Yeah, go ahead.
Thank you for your talk.
You're welcome.
So I'm just wondering, how is Veracode different from your typical SonarQube or GitHub code scanning? I didn't know about Veracode before, but it sounds like it's doing the same thing as SonarQube and GitHub code scanning as well.
GitHub Advanced Security. Yeah, you're right. It's a hugely competitive landscape today. I think the biggest element of it is in AI security and the focus on securing code that way. But SonarQube specifically is a QA tool that offers some AST scanning capabilities, but the AppSec space is a very competitive space for sure. We see that every day.
I have been told, and I hope you'll tell me whether it's right or wrong,
Sure.
that prompt engineering can reduce the amount of vulnerable code you get if you use an AI coder. If you instruct the AI to give you secure code, it is far more likely to do so. How accurate is that?
Yeah, good point. Yeah, very good point. The thing is that what I've seen across the board and when I've tested some of these solutions to create or use prompt engineering, or actually just to use AI to analyze my code, I think it is increasing and it's getting much, much better. It's not quite there yet. A lot of the hallucinations, and the thing is, it's like a double-edged sword, that it's checking your code for AI or checking your code for security, but on the flip side of it, where is the source from and where is this code? So it's kind of a double-edged sword. It's difficult to, I don't think it's quite there yet, but and how this code is trained, you don't know the data sets from these various different models. I hope that answers your question. You're welcome. Any other questions? Let's go for last question.
Hi. So hi, I got a couple of questions.
Oh wow.
It's quite. So how do you when you're training your model, how do you because I assume it's like millions and millions of lines of code.
Yeah.
I assume you have better things to do with your day, so you don't really go through every single one looking at with this break, with that break.
Yeah.
So how do you like on a large scale figure out what is shitty code? So what is good code and what is the kind of code that I will write, which is shitty? Um,
Yeah, that's a fair point.
I mean, okay. So next question is that like, okay, what is the difference between? So we're all human beings, right? So like, and we've all at that point we've been on like 3 cans of Monster. And we are like trying to get this feature out. So we don't do the best things. So
Yeah.
like, what's the difference between when an LLM generates that code versus us? Like, which is more safer to be in a real world experience? Which is more safer? Because I've seen LLM code. It
Yeah.
does better than me
Yeah, yeah.
sometimes. So then the next question is no, it's not the last one. So the formula, that formula, which is the formula that you showed, the A plus B minus C.
Yes.
Sorry, I'm very technical. As you can see, I was really like, could you explain that just a little bit more? So it's more like it's. I mean, I get it on just by looking at it. I get the concept.
Yeah.
But I'm having to understand like, okay, you have good, you have bad. You try and separate the bad out of the power, and whatever remains is good.
Yeah.
How do you know what is bad mathematically? Um, um, yeah. Would you guys ever support like Olama so that we can just run the model on our system, like the whole Veracode model on our system, so we don't have to like, you know, like I'm assuming that right now we connect to like your API. Is that how it works?
Yeah, API creds.
So like,
Yeah.
is there like going to be like if maybe like a lower skill model that we can download with and run with Olama or something like that? And yeah, very importantly, how do I get that
Gosh, that's a
ATM
lot of
hack
questions.
code? No, this is the last one. How do I get that ATM code, ATM hack code, and the warm GPT for educational purposes, of course?
Wow, that's a lot of questions. You'll have to remind me. So first one, how do we train our data set? We've scanned trillions of lines of code. So using that code and our security research team, engineering teams, curating that internally. So using the power of GPT, but at the same time, also using the code that we've curated and scanned ourselves. Second question. B is equal to A.
Yeah, the A plus B minus C, that whole you have good code and you separate the bad code out of it.
Yeah.
Whatever remains is the good code. How does that work technically?
So it sounds like I need a second talk to go through that. It's based on reference patches. So looking at vulnerable references. So rather than analyze entire piece of code, just when I presented that cross-site scripting, actually looking at that piece, that was the vulnerable piece, and how you would go about cleansing it. And in answer to the ATM as well as the dark web, I don't know. I have not tried it. I don't think I intend to to try it. But do you know what? It's probably accessible. I wouldn't be surprised. But all right, I think I'll hand it back. Thank you very much, everyone.
Thank you for the presentation. I think it was really interesting to learn about security with Veracode and AI. Is this working? Yes. So the next speaker will be Shubhangi about evaluating LLMs. We will need around a minute to set up the tech. I'm curious, how much of you, if you use fine-tuned LLMs in your practice, either for your personal project or work, just put up your hand. Okay, so it's like maybe 10%. Okay, thank you.
Join the meeting.
You need to start sharing. Yes.
Hello, everyone. Good evening. I'm going to run a session for next 20 minutes on evaluation of LLMs using prompt engineering. Before I start, I'd like to give a quick introduction about myself. I work in data analytics at ICS, focused on UK public sector. I'm a speaker. I've spoken on multiple different places you can see on the right. I'm a mentor. I've been a mentor at FemiPalette. It's a Prague-based organization at Unstop, and I'm also a mentor at TopMate. I previously worked for Tata Group for TCS Microsoft relationship as well for 3 years. Pursued computer science engineering as my first degree, and then I transitioned into business analytics. In my free time, I like to travel, read, and hike, and that's just me in summary. So before I start, I'll run the agenda. I'm going to cover from overview of LLMs to the role of prompts and how they're used in assessing the LLM capabilities, understanding some of the methods that I used, and at the end, I'm going to show a use case that I've created for evaluating the LLMs. So before I start, how many of you are data scientists here? Can you please raise your hands? Cool. How many of you have worked on natural language processing? Okay, a few. And how many of you have used prompt flow? Okay, cool. So I'm pretty sure everybody already knows it, but let's start from the beginning if anybody doesn't know what generative AI is. So it's obviously a series of algorithms used to create new content, audio, video, and text images. And obviously it's trained on large parameters of data. ChatGPT-3 was around 570 billion parameters. And obviously we have now a lot more than that. The main part of this talk is evaluating LLMs. As was mentioned in the previous talk, it's important to make sure that they are coherent, the answers that they generate are relevant, and they're effective as well in the real world. So whenever you're creating any application and not just using as an end user, you need to make sure they're actually good. And then we have prompt engineering, which is basically the practice of designing inputs that are used to guide those model responses. And they essentially play a very significant role in assessing those LLMs. And essentially, what I'm going to cover is some of the biases, limitations, and efficiency. That is the part of my talk. Before I go further, how the landscape changed. Now we have pre-trained data. A lot of the data that we have is around a lot of text data from nuances of human language. We have continuous learning models that are constantly training on its own. We have context. So everybody has used a chatbot. We all know how clunky they were back then. And now we have more meaning to the words. They understand and they have way more resources. Then the fourth thing is nuances. Nuances of the human languages, slangs, idioms, and intonations are understood better. Voice, speech-to-text recognition, when combined, obviously, is way more powerful. And my use case is basically tied to the fifth one. And lastly, query interpretation, which is mostly around multi-part or complex conversations. For example, somebody asks many questions in one single statement is definitely understood better. The very important part of LLMs is context, because that is something which we used to lack before, because LLMs are able to understand the context better. They're able to remember the previous exchange of messages and generate responses which are more adaptable. They're able to handle the ambiguous situations, phrases, intents very well. And then last part is adaptability. They're useful in dynamic environments where the responses need to be really flexible. They're not very one-to-one responses and structured. So at the end of the day, what I mean is like context is extremely important, especially if you are very sector biased. Like if you're using in healthcare, legal, politics, if a sector is important, then please make sure your context is right as well. And finally, these are some very NLP focused capabilities, sentiment analysis. Like some of the initial analysis I did using Python was quite basic. And I think LLMs are way more powerful in understanding human emotions. Semantic searches, like the keyword-based searches have gone beyond a normal meaning, like what a word meant. They're way beyond, and it understands, recognizes user intent better. The third thing is summarization, which I think pretty much everybody would have used right now. How do you summarize the data? And then lastly, we have text generation. A lot of companies out there are using synthetic data. They're able to generate more and more data from existing data. And they're basically using that dummy data for training purposes. Now, role of prompting in LLMs. Prompt engineering, as I said in the beginning, is extremely important if you want to use generative AI effectively. So the first one is pretty basic, zero-shot prompting, where you are just providing a single given task without any prior example. Then the second one, which is called a few-shot prompting. We have given basically some examples to the LLM to understand what kind of prompts are going to generate. So you can see some of the examples I've written. So the session is not about training on prompt engineering, so I'm not going to go into details, but I'm pretty sure most of the people would have already tried it. And the third is chain of thought reasoning, which is quite important because it encourages step-by-step reasoning. So it's like conditional statement. You give a condition, they understand the condition, and they basically give a response based on the reasoning that they have. Now, some of the methods of evaluating LLMs. This is from the end user perspective, if you're using it as a user. So first is the comparative prompting, which is an evaluation technique where generating prompts and analyzing LLMs at different levels. The goal here is to just understand how the context changes and the answer changes, and is the answer more accurate, relevant, and high quality output. The second is human versus automated prompting. So in this one, either you are involving an expert, which is a subject matter expert in that area, who is generating an output like a coherence, relevance value, or a fairness value. You can use metrics like BLEU, BERT, or perplexity. BLEU is mostly used for text similarity, where people are using it for summarization note. BERT is used for semantic similarity, and perplexity mostly for measuring the relevance of one word to another. And this is very specific to natural language processing cases only. And the last one is adversarial prompting. So this is where anything is misleading or ambiguous. So if your data, for example, somebody's performing any hiring or somebody's using it for certain purposes, this is extremely important that your data should not be biased. It is fair, ethical, and responsible. So if you create an application, if you're the end user, and let's say your application is being used by a 60-year-old person, how will they ensure your output is correct, right? So you need to make sure everything is in line, your outcome is coherent and relevant. So the third one is used to identify any potential biases, any kind of failure cases in the model responses. Some of the examples. The first one is of comparative prompting. You can see prompts 1, 2, and 3 that I've given. They're very simple to compare and simple to understand. One is about just summarizing it. Second is about changing, about giving more about 50 words. And the third one is more about telling a friend. Second one is about generating a BLEU score. So basically, you're writing an algorithm in this case, which is where you're comparing the reference text that you are generating. It will generate an AI-generated translation which matches a human-generated. So if you are creating like a multilingual system where you are supporting multiple languages, let's say Welsh language, Scottish language, let's say Hindi language, any language you are generating and you are developing a conversion tool, so in that case, the second case will be useful for you to use and evaluate how well your AI-generated answer is good or not. And the last one is adversarial prompting. So I said in the previous slide, there are multiple ways obviously to do it. The answer should be ethical and there should not be any misinformation, which also was discussed in the previous talk about hallucinations. So for that, you need to make sure that there are no logical contextual errors and there is bias testing involved. So one of the examples, which is pretty simple, I gave this to ChatGPT, and basically this is what the output I got. It was just a very simple logical. I'm asking ChatGPT is 2 + 2 = 5, and I would expect it to say that it's arithmetically wrong, and well, it did a good job there, understanding arithmetically it was wrong. But then he explained me why it could be 2 + 2 = 5 and gave me a couple of examples. This is a very basic example, but it could be used very well for some of the cases where fairness and biasness comes into play. Now I'm going to go to the use case that I have created. So this is the terms that I use in natural language processing. So there are 3 statements on the screen. Can you tell me about tax, and then there is the third one. So these 3 things indicate user intent. Intent in natural language processing is anything, basically the first step of why you ask the question in the first place. Your goal here was to understand about this particular thing, right? So the first one is called more sort of optimized input. The second one is called sparse or the terse input. And the last one is just descriptive input, or which you can also say a verbose input. Basically, you're providing too much information in one go. Now I tried all 3 of them, and my questions were, how different are these? The answer, is it relevant? I mean, what is the user intent? Because in the third one, he wants to know about tax, also want to pay it, and also wants a receipt. Basically, he wants 3 different things in one go. So this is the first part. So for that, I generated a use case of response evaluation. Now, why it is necessary? The first one is relevance. You have to assess whether the question and the answer, they address the core issue effectively. Second is accuracy, evaluating the correctness and reliability of your information. So if you're asking about tax and the links it's providing, is it correct or not? Because sometimes it generates false outcomes. Third, clarity. Your response is clear, concise. Is it easily understood? And what is the impact? Because that's what matters at the end of the day. If you're creating any application, if you're building anything, what's the impact it's creating? And that's where the whole deal lies. So you have to measure the effectiveness of your response, because end user, they only care about that. They don't care about what you're creating. So here we are with prompt flow. So Azure ML prompt flow, it's a tool which is designed by Microsoft. It's a part of Azure AI workspace. It is used effectively by many people, but I mean, I would say AI developers and data scientists, but anybody can use it. If you're not somebody who is a coding expert and you would like to use it, you can still use it. You can certainly generate code from ChatGPT with more responsibility. So what it does, it basically has one part. It's called a visual window. It basically contains an input. You can create multiple nodes. This is for LLM, this is for Python, and then this is an aggregation node, and there is an output. And the input looks something like this. On the left side, on the top, you can see I've given a question, for example, a context and an answer. So basically contains 3 string values. Now this is one single, you can give multiple inputs as well at the same time. And this is how the description looks like. When I open description, it just gives you more description. So before we go and see it live, I think I want to cover 5 main things about prompt flow. So first is it's a visual flow builder. This is the best part that you can visually see. So if you have designed packages, data warehousing packages, a lot of them actually contain visual builders, which is easier to understand and interpret. Second is you can experiment with your prompt way easily than you would do in any other application. Third thing is it can integrate with other models and tools pretty effectively and easily. It's something you can create even if you're not an expert in coding. Fourth is automated execution monitoring. Once you set up a flow or build a RAG application, you can automate the entire execution. And your teams can collaborate in one go. Like you don't have to create separate prompt flows for everybody. So this is a structure. So in the first part, there's like a prompt that has been written. It's for Q&A relevance. Basically, you're trying to find if your answer is relevant or not. So this is your node here, and this is a sample Python code. So obviously, you will have to write the Python code yourself. I can't teach that. But the first part is the prompt that we are using. So I've given a relevance value. I'm saying if the answer is completely irrelevant, just start it as 1. If it's really good, give it 5. And then similarly, I've given a complete example of how we should classify from 1 to 5 for a Q&A relevance scoring. What it does is, it will generate output metric. So firstly, when to use it, how to read, relevance and scoring. You can only use this one first when you want to enhance your user experience. So I think when somebody builds an application, you always want people to come back again, right? Like if you're building a website, if you're building something, you don't want somebody to use it one and go away. So it's important that your user experience of the application is extremely good. So you use it when you want to enhance the user experience and basically maintain and develop great generative AI systems. How do you read it? So the answers are scored in the ability to compare the key points. Basically, it will understand and see how the context is visible and related to the question asked. It can be anything. It doesn't have to be something I have written. Then the relevance score is basically provided based on coherent and contextually relevant outputs and its scale. The scale is 1 if it's relevant, 1 to 5. You can basically have 1 to 3, 1 to 10, or whatever you want. You can customize the entire prompt. So when I tested it out, it generated a couple of values. So for example, it will generate something like this. You will have an input answer, a status, and a GPT relevance value. And this is basically whatever GPT model you have selected. Or you can run a batch of 1,000 pairs at once, which will basically give you an output based on whatever pairing you will provide, whatever question context you will provide. And small differences in the way you have structured the entire thing will actually give very different answers. So if your prompt flow is not well structured, then you might not get what you desire. But there are limitations again. So first one is ambiguity. Sometimes when you will give similar questions or answer, you will find it's very ambiguous. It might not give correct outputs. Repetition, there could be lack of consistency within the same queries, which I don't think is good. So if you're asking same question, I would expect same answers for the same set of question. So lack of consistency is not good for same set of questions. Domain is very important. If you are in healthcare, legal, or politics, or something very specific, you need to make sure domain is correct, because the different words mean different in different domain. If you are using it for specifically medical purposes, any kind of application, extremely important to make sure domain is right. And then lastly, you have user experience. The model should know its purpose. If it knows its purpose, you have to adjust the outcome based on that. So where are we going with this? To solve this, we use three things. Grounding, extremely important, using RAGs. I'm pretty sure people would have heard RAGs, what RAGs are. And they make the model both trustworthy and reliable because you are able to perform more complicated prompting using RAGs. Topic islands, you create cluster of content that you're basically using. So if you have specific topics that you're using, you create topic islands through that. And then lastly, semantic chunking, basically building relationships between those different syntactic pairs so that you're able to generate more accurate and reliable responses. Key takeaways from this is, obviously the first thing, context is important. Please make sure that you are rightly putting that into place. Second is prompt engineering. You have to be a master of it if you want to use it very well and effectively. If you don't know how to communicate using prompts very well, then you have to learn because generative AI runs on it. Third is model parameters. Modify temperature settings and case sampling that is using the data. This is important for balancing the creativity in your answers and relevance. And then lastly, feedback loops. If you don't get the right answer in the first time, you have to make sure that you're using feedback loops very effectively. So the LLM is basically able to generate outcomes which are more reliable. Now I'm going to show the demo. All right, I'll have to switch my screen. Okay, so this is how the prompt looks. I don't know why this is coming, by the way. So anyway, this is Azure AI Machine Learning Studio. On the left, you can see this is the prompt flow. This is one of the applications. It has a lot of applications, by the way. So on the top, there are different blocks. There's an LLM block, a prompt, a Python block. You provide an input here. And this is like really one of the simplest versions that I'm showing here. I only wanted one metric. So I created a GPT relevance metric, but you can create way more. Like you can generate coherence, you can generate accuracy, you can also create your own metrics. It's totally flexible. Then you go downwards, there's a small block. So this is the prompt block. I've given, for example, a Turbo GPT 3.5, but I would suggest use the latest model. It's way better. Then I've given a prompt here. I've given an example of like how it should work, what kind of relevance it should give, what's the classification of the relevance, how it should understand it. So it's a very, very, very detailed prompt. I've given everything to the prompt flow here. And then as you go downwards, I've given it a Python script here, which basically concatenates the entire score. So whatever scores you're generating individually, it will concatenate all those scores and generate a final outcome on the last part. And here on the right, if you see, you will be able to see this visual flow diagram, which is primarily used to just show the same thing, but in a more sort of visual format. It's way simple, but the ones I've built for RAGs are way complicated, but I can't show it right now. So this one is the way you basically are able to create a prompt flow for your own application. You can also do batch runs on it. It will show you status here on the top if it's accurate and completed. You can also see outputs like this. If you click on this one, it will show you an output window. So for example, the one I ran, for example, there's a score generated here. You can see the logs in this window, whatever logs has been generated. You can see the metrics. For example, I have only one, so it will show you the metrics here. And then lastly, you have a trace. If you have any trace created from your flow, it will basically show any kind of traces here. So this is how the output looks like. But you can batch and also a couple of data together. You have to put them in a spreadsheet, give it a format like a CSV or TXT file, and whatever data you will generate. If you want it to run for mass data, then you will have to create a RAG application. It works way better for that. And with that, I come to the end of my talk. And that's me. Thank you very much. If you have any questions.